Welcome, guys and girls, to another exciting session of chemistry. For those of you who don't know about this channel, I'm going through the new AQA spec for chemistry, and I'm going to go through chemistry, biology and physics. So the next breakthrough in the atom, the structure of the atom, was between two scientists called Geiger and Marsden. Now, these were two scientists who were under the supervision of Rutherford, so it's also called the Rutherford Experiment. Rutherford. So if you like, Rutherford was the boss, these two were his students. So what did they actually do though? What they did was they fired an alpha particle. They fired an alpha particle through a very, very thin piece of gold. So it's a thin piece of gold, and they wanted to see what this alpha particle, which has a positive charge, would do as it passes the thin piece of gold. Now what you got to remember is that the theory of the time was from the Thomson experiment, which is that the positive is all spread out and the negative is held in place as well. So you got to remember that the positive is spread out. Now if the positive charge, as the Thomson experiment held, was spread out, then if you've got a positively charged particle that's being shot at a high speed, what you would expect it to do is to just go straight through, because the other positive charges within the atom are really, really far apart. They're not really going to affect it. This is what they expected based on the J.J. Thomson's model. However, this is not what happened. What actually happened was that alpha particle, as it fired through, some of it, yeah, absolutely went straight through. However, some of it, as it went through, it ended up being reflected or deflected away. And this was like not expected. So what they thought is that, you know what, this model here, in which the positive protons are spread throughout the atom, must be wrong. And what they proposed was a different model. What they suggested is the following. What they said is that in the middle you must have a positive center, right, and around it you probably got electrons, right? So what they suggested here is that now if you fired the positive alpha particle, at certain points when it hits the positive nucleus, it's going to reflect or be deflected away, right? Whereas if it's not hitting, so if this is another alpha particle, if it's nowhere near the positive center, then it'll go straight through, because it's not being reflected away. Because remember, opposites or the same charges will repel each other. So here we've got repulsion from this alpha hitting the nucleus. Here, because it's far away from the positive nucleus, it's going to go straight through. So because they detected this repelling, so because they detected this repulsion, this told them that the center of the atom must have a positive charge. And so now we're moving away from the plum pudding model, and we're saying that actually there's a positive nucleus, and around the positive nucleus there must be negatively charged electrons. So far what we've looked at is, number one, we've proved that the electrons are negative, and number two, we've proven that there is a positive centered nucleus. So in 1914 there was another discovery by Niels Bohr. What he discovered was how the electrons are arranged, because what he did was that he everyone was happy now that the nucleus is positive, but the placement of the electrons was a problem. So what he did was he ended up heating up the electrons, or the atom of the element, wherever it might be, and what he noticed was that the electron would give off energy. So once it went to a higher electron shell and it went back down to its original shell, in the process it would give out light. And what he noticed is that every specific element would give out a specific amount of light, and that's because the electrons would jump from one electron shell to another and then back to its original place, or back to its original shell. And so what this proved is that the amount of light energy it gave off suggested that the electrons are fixed distances away from the nucleus. So this suggested that the electrons were fixed distances away from the nucleus, and that they all had to be in electron shells, that they just weren't randomly scattered around. They were in fixed position. If you heat them up, the electrons would have enough energy to move to the next electron shell. When they returned back to the original electron shell, it would give off that energy in the form of light. And so he suggested that electrons are in electron shells. So the last thing we have to now think about is where are the neutrons? How were the neutrons discovered? So we've got, so far we know how protons were discovered, electrons and their placement, so electron shells, and finally we need to know how neutrons were discovered. Let's have a look. So now we're going to look at how the how neutrons were discovered. They were discovered experimentally by a person called James Chadwick in 1932. The question is, how did he discover them? Well, what he did was he used alpha particles as well. Remember, alpha particles are overall positively charged, and so he shot them at a very high speed at beryllium, boron and lithium. And so as he shot these alpha particles, so there would have been loads of them, he noticed that it caused the beryllium, boron or lithium to release something in return. Now what he did is he applied a positive and negative charge to each side. So there's a positive plate here and a negative plate at the bottom. Now if it was positively charged, if these rays were positively charged, they would move to the negative, and if they were negatively charged, they would move to the positive. However, when he did apply the charge, these rays that were coming out, the lithium, beryllium or boron, did not move to either side. So what this shows and what this demonstrates is that whatever it is, there is no charge in there whatsoever. So it can't be a proton and it can't be an electron, because remember, a proton is positively charged. So a proton is positively charged and an electron is negatively charged. By the way, this, guys, is how you write electrons once you get to college and university. It's the shortcut way of writing it, and the reason why it's written like that is E stands for electron, and that negative shows that it has a negative charge. So they know that it's not positively charged and it's not negatively charged because it doesn't move when you apply a positive or a negative charge external to it. So the first thing that they've discovered is that whatever this is, mystery object, it has zero charge. Zero charge. So they're on their way to making some discoveries. Then what they did is they took some wax, right? So this is my wax, and they wanted to see what would happen if they let this mysterious thing hit the wax, and they wanted to see what got knocked out. And what they discovered is that what got knocked out were the positive protons. So this thing, whatever it was able to knock out the positive protons. So how did they know it was positive? Once again, you just apply a charge. So here's my positive charge, here's my negative charge. Now since the protons are positively charged, are they going to move to the negative side or the positive side? Think about it. They're going to move to the negative side because opposite charges attract. So what's so interesting about this result anyway? What they discovered from doing this is that, let's think about this. Let's say you've got a ball, right? And the ball has a mass of 1 kilogram, for example, right? And you've got a fly. So here's my house fly, right? Or let's make it a spider because it looks more like a spider. So here's my spider. Now it's a tiny spider. If I shoot this spider at this 1 kilogram ball, is it going to move the ball? The answer is no. Now let's say I've got a 1 kilogram ball here and I've got another 1 kilogram ball here. If I shoot this ball at ball A, we'll call this ball A, at ball B, is ball B going to move? Yes, of course it will. So what they discovered is that whatever this mysterious object is going to have the same mass as a proton. So now they discovered that the mass of this mysterious object is also 1 because it's the same as a proton. And so by doing this, they discovered, number one, that a neutron has no charge, and number two, that it has the same mass as a proton. And so bringing all of these ideas together, starting from the 1800s all the way up to 1932, they discovered protons, electrons, and neutrons. Takes a lot of hard work and a lot of thinking. And with the discovery of electrons, they discovered electron shells too. I hope that clears it up. Do go back in the video, see what you understand, what you don't understand. If there's something you don't understand, be sure to ask me either at school, or if you're not from my school, at the comment section below.